I've got the tweaks, the adjustments I made to the actuation core switches, which is basically some little bridges, a bit more steel across the bridging. And I have this meter, the white meter is reading AC input to both the coils. I have twin actuation coils to actuate the magnetic switches, which are on both sides, and I have biasing magnets to offset to create the balance at the moment, because the magnets on the inside are slightly off center, so we have to compensate to balance the unit. Now, when I load the coil down, and the coil is currently outputting 48 kilohertz. Now, when I put the meter on the output coil, shorting it out across the meter, the output is currently 63.9, 64 milliamps AC. Now, and we can see the actual change on the input current on this white meter, which is what's driving it. So when I put this back on frequency, which is when it's not loading the coil down, you can see the change of frequency 352, and it's actually hardly even changing, right? 352.1, put it back on current, 352.8, right? So shorting it out through the meter, 64.2 milliamps AC, back on frequency. Now, if I short the output coil out with a resistor, a 100 ohm resistor, which is according to Z, which according to all electronics is true power, we can see how much change we have on the input there. So I'm now loading it down with a 100 ohm resistor, and it's reading 351.7 milliamps. Take the 100 ohm resistor off. Oh, maybe it wasn't connected, hang on. Right, 351 points. Let me make sure this is connected properly. 351.7 milliamps on the input. Take the 100 ohm resistor away. Oh, it's not changing. It usually changes a little bit. Hang on, maybe I wasn't connected, I'll just double check. Right, I'm loading the output down with a 100 ohm resistor. And it's 351.8 milliamps. Take the 100 ohm resistor off. 351.8 milliamps input. It's not changing. Now let's short the output. Now the output is directly shorted now, and it's dropped to 354.1 milliamps. So it's gone up to 354.1 milliamps. Remove the short, it's 351.8 milliamps. Right, the actual AC output, we're no longer shorting it, by the way. The actual AC output is very small at the moment. It's about half a volt. It's 0.51 of a volt. Half a volt, but we should still see significantly more change because of all the current we're drawing, pulling off it. We should see a much bigger change on the input, and we're not. So we've actually only got a half a volt at the moment on the secondary coil on the output. And we're getting, once we get this tuned properly, once we get to the right resonant frequency, because we're only running at 50 Hz right now on an AC transformer input, we don't actually have a tuned frequency in here yet. When we find the proper resonant frequency, we should get more output. That's something I'm going to find out once I build the circuit Hopefully in the next week or two I should get that sorted out. I've got to do some testing on a breadboard first before I actually build a final circuit board, but I'm going to do some tests with to find the actual optimum frequency to run this with. So anyway, that's just an update, short update on the situation we have at the moment. So this is input, this is output, and we're currently on voltage which is 0.51 volts AC. Now I'll put this back on current, and it's pulling it down by 64.2 milliamps, and you can see for yourself the changes on the input current which is negligible bubble, yeah. So I'll put this back on current now. We've still got a lot of tuning to do, because also if I remove the magnet biasing, you'll notice that the current output drops quite a lot, because it still has to be tuned properly. These just adjust the magnetic switching inside, and we have more core material to add as well.